Welcome all. This is Sunil Kurpa, and I'm recording this video to present my project under CS441, Distributed Cloud Computing under Instructor Mark. So let's dive in. So my project is Hadoop-LLM on AWS-EMR, large-scale text processing and embeddings. The problem statement is, so when we have huge amount of data which have to be processed by machine learning programs or natural language processing programs. So having a single standalone machine is very difficult, and as the size grows, it becomes very difficult to process the data. So here I have used an AI image on the right, where a donkey is trying to carry a huge load, which can be compared to a single standalone machine, which is trying to process huge amount of data. So what's the solution? So the solution is used to distributed programming to uh, solve this problem. So we are using MapReduce, which is developed by Hadoop. So we'll be using a MapReduce pipeline to process the data in a distributed and parallel fashion. And we'll be deploying our application on the AWS EMR. So I have an AI image which shows multiple donkeys which divide the load, which can be compared to distributed programming, where we split the input file into multiple MR programs and we can achieve our results faster. So the core idea is that we have two programs. One is tokenizer and one is embedded. Tokenizer is a MapReduce job which will convert the actual data into words. Then these words are converted into tokens using an encoder. Next program is embedding generator. This is another MapReduce programs where it takes the tokens and generate the vector embeddings after getting trained by a neural network. Here's a high-level diagram of how things work. Everything is in the AWS cloud platform, and input is a huge data, and it's being stored in the Amazon S3. I've used CNN news summary as an input data, which will be fed into an EMR cluster, which contains two EMR programs. One is tokenizer and one is LLM EMR. We'll look into this individual EMRs later in the presentation. Then after the results are processed, it is again stored in Amazon S3. Here's a simple program to understand what MapReduce program is using word count. This is also part of our tokenizer program. So firstly, we have an input which will be splitted into multiple units and fed into the mapper. The mapper processes the data, and the output of the mappers are shuffled and sorted. So the sorted inputs are being fed to the reducers again, which actually sums up the units based on the keys, and the final result is produced. So in the final results, you can see that the bear word is repeated twice, and the car word is repeated thrice. Similarly, other words. About our program 2, Hadoop embedding mapper, which takes in the input string, which is a large corpus of data. The data is then converted into tokenized text, where each word is being unitized, and we'll convert this tokenized text into token IDs using an encoder. Then we'll convert it into token embeddings, and we can also define the dimensions here. Higher the dimensions, the we can capture more complex patterns, and it is fed into the GPT-like transformer, where it will learn the embedded tokens, and based on the number of iterations, the learning is accurate. Higher the number of iterations, it learns well, it learns more complex patterns, but if it is too high, then the model might be overfitted. Then the output of the mapper is again the token embeddings, but these are adjusted tokens after the learning is completed. So what does the reducer do? So it actually accumulates all the mapper results. Each mapper is a list of token embeddings which are fed into a reducer. Reducer will average out this vector embeddings. Let's dive into a demo on AWS. So in AWS, first part is S3. We need to have a structure where we have input file, input folder, jar folder, and output folder. So for the input, for the testing purpose and for the demo purpose, I've taken a small input, which is a text file. But I did train based on the large input, which is the CNN summary. data. It is of 1.2 GB. Next is we have a jar folder where we will place our common jar. Then the output folder where we can expect the output to be present. We'll learn is we'll run a sample program and see how the output and will be. So I'm creating a new cluster. New cluster. I will use the latest EMR release. I will select only Hadoop and deselect everything. This will reduce the startup time. You have to leave everything to default. Task, we don't need a task because we'll be creating a step function. We'll leave the task. Leaving everything as default. Networking, I have default VPC and subnet. Next is steps. I need to have two steps. First is the tokenizer. Need to provide the jar location in the S3. So it is stored under homework1 jar. You copy the URL and paste it here. I'm passing arguments, which is actually my class names. I'll select this option to terminate the cluster after it finishes. Fun, completed. Step 2, a similar approach. We have to do it for embedded. The jar will be the same jar. It's just the class path is different for these two jars. I have an embedding class, which I'll be using. We'll select an EMR. We need an IMR rule for this, IM rule, and also EC2 instance profile rule. So what does this IM rule contain? I can just give a quick review of that. We do have permissions to access the S3 fully, and there are some EMR policies, and this also EMR contains the access to EC2 instances. Similarly, we have an instance profile for EC2. So I'll create a cluster. This will take some time. In the meanwhile, we can dive into the code and look how things work. So I have an application config, which is pretty cool. I have 3 sections, and coming to the for example, if I take file system, I have variables like local, test, and prod. So these are used based on the development phase. If you're developing locally, you can set it to local. If the test automatically use the test config, and production is the production config. For example, for the input directories for the local, we'll be using the HDFS directory, and for the test, I have some test data in my resources here locally, which will be using that, and in the production, we'll be using an S3 bucket. And this is about the structure of the application config. And coming to the individual configurations for the Hadoop, we are using the reducers as one, and split size as 256 MB. This is somewhat dependent on the number of iterations that we do for a neural network and the neural network vector embedding dimension. The Hadoop recommends that for a given job, for a given mapper, it should complete its job in 1 minute. So I did some experimentations and found out that this 256 MB configuration works out well for us. So I do have some names for our jobs. Input and output directories for having the input and creating the output pretty straightforward. And we have an embedded job. It is a vocabulary size of 200K, and I'm using embedding dimension of 100 and number of epochs as 100. So about the application config, jumping into the code. First thing is tokenizer. For the tokenizer, we do use an encoder which uses 100K as a base. So basically, it has 100K words in this vocabulary. Next is coming to the mapper function. It basically divides the string based on individual words. Then we are encoding the words and we are sending it to the output. Simple. Next is in sum reducer. It basically sums out the words based on the key. I do have some utility functions like encoder and decoder, which is being used in multiple places. This is the main program for tokenizer, which was part of the step 1 function. I do have logs to check my progress of the working. Next class is embedding class. So this class we do load the config from the configuration factory, and yeah. So the mapper, what it does is that it divides the input into sentences, and we do provide synchronized sentences, which is a 2D array. Then we flatten this 2D array into 1D array. We flatten into tokens and labels. This is required for the sliding window logic. Then we convert the 2D array into IND array, which is a compatible format for the neural network processing. So we create a neural network with two layers. One is embedding layer and one is the output layer. The output layer uses the activation function softmax, which is required for the text classification functions. We could add more hidden layers to increase the learning patterns. But yeah, then the model is initialized, and um, it is ran for a number of iterations. I do have logs to provide the progress of the training data. Next is that we get the embeddings, the learned embeddings, and we again feed it to the output. So our output is a key. Keys the words, and the values are vector embeddings. What does the reducer do? Reducer basically takes the vector embeddings, multiple vector embeddings, and it averages out and it's put it into a file. It's pretty simple. Next, we have the main function, which is the main function of step 2. It's kind of same as step 1 main function. So these two have something in common, that is running a job, and few of the configurations are common. So what I did was we have a class called job configuration, which actually has an environment, production, local, or test. Based on the environment set, we will fetch the corresponding variables. Next, I have a utility function to create the job, which actually depends upon the configuration file. It sets all the required file system, number of reducers, what is the split size, input output path, things like that. I do have a utility function to pass the text, calculating the average, things like this. So this is of the main class. Diving into the test, I do have some input files here, which are small in size, and I do print the output here itself. These are Git ignored, so they don't really move to GitHub. Next is about the test. I do have it's a test class for tokenizer. So basically, it validates the encoder and decoder for valid inputs, empty inputs, invalid inputs, things like that. And I do have integration tests for mappers, reducers, and I do have an end-to-end test which runs both the mapper and reducer locally and produces output itself. Similarly, for embeddings, I do have a unit test to check the validate the vector embeddings if they are produced or not based on some valid inputs, empty inputs, and invalid inputs. And for the reducer, I do have a test to check if the average is working out or not. And I do have integration tests for mappers and reducers as a whole. Then at last, I do have an end-to-end test which actually runs the whole job end-to-end and produces output here. So that's about the test. Yeah. Let's check on the demo cluster what we got running. Once step function is completed, one more we'll come back to this. Locally, for the testing purpose, I have used HDFS, and I do have the data here. And let's look at a sample input here. This is the output of the tokenizer. For each of the input, what is the token, what is the vector, and how many times did it repeat. Similarly, for embedding job, for a given word, like what is a token and what is the vector ID, we're printing this. We should be seeing similar results in our AWS as well, which we'll look at it later. So this is my GitHub. I do have a README file which defines the project summary, project structure, prerequisites required to run, and the steps to execute the project, how we clone, how do we prepare our project in the AWS, what based on the environment I can run it. You can just test it out locally also, or you can just run a simple test, or what are the things required to run in the production, and other steps if we are doing it in production, deploying the application to the AWS and checking it out. So for the test, I do have a coverage of 96% overall, and individual test coverages can be seen here. You can see that both the step functions have been completed, but the logs are not posted for this. We'll wait for that. But I will have a quick look into the logs of the first program. So you can see the number of splits that happened, number of reducing jobs. It's a small file, so uh, the logs are very less. But yeah, if the program takes a longer time, you can actually see the CPU time, the memory consumption, and things like that. It's a controller logs where you can find the paths and all. It's mostly used for debugging purpose. Yeah, similar to that. So this is a second function which is pretty complex than the first one. So we do have a lot of logs. So here you can find the number of splits that happened, and also some important things like the number of bytes read, number of files read, and things like that. And it also has CPU related, CPU memory related stats as well. You can find them. We have like mapper and combiner reducer outputs, very similar to databases. Yeah, this is all about the logs. Let's see the output. Um, the output, as I said, it will be in the output folder. It was modified. Okay, okay. So this is a sample output for the LLM encoder. I'll download it. Let's check it out. The dimension is very long, so it's pretty hard to understand. I'll go to in the middle. So you can see that for the word became, this is the token, and this is the vector ID, which is of size 100. So that is output of uh, program number 2. We have a tokenizer output as well. This is like the word program. Yeah, like the word 100R. This is the token ID, and this is how many times you can repeat it. So yeah, this is about the AWS logs. I think we are done with the demo. Thank you. I forgot to show you the end-to-end working, so just take a video here. I'm running the embedding end-to-end test. So I have my input files here, or should be created there in the output folder ideally. Run it. This is for the embedding spec. Yeah, the job is complete. I wrote the results here. You can check that. The word, the token, and the logged embeddings. I run the token as an end-to-end test. Try and pretty quickly. See the output. I run the tokenizer here. So you can see that. This is the word, this is the token, and it is repeated one time. Cool. Next, I'll be running the functions locally. So I have a main class and also have a job config which denotes that environment is local. So we're running the tokenizer first, and my outputs are to be expected in the HDFS local machine. Times 11:57. So if I go to check this, with that, where I run the other program, it might take some time for it to appear here. Yeah, star 57 to come as the output, part 0. You can see the check line, the visual is appearing once the token. Go back. The other program completed as well, localizing the output should be expected to be here. Refresh. Yeah, land page. So part 0. Now, for example, the whole world token is rectangle. And it is all I have run a test and also admin classes locally. Thank you.